Captain Peter Cutsey, South Korea, and this is my briefing room. We are in Oman, that is at the airport of Muscat on the north side on radar vectors for an ILS to runway 08 left. The object of this lesson is to demonstrate how to recover from being vectored too close and too high to actually intercept the glide slope on an ILS approach. Let's go and have a look at the PowerPoint you see on screen. We'll talk about it, then we'll go into the simulator and we will fly it. Well, this is our position here, not to scale, but on the moving map. And we'll go to the PowerPoint, one of over 500 that I have in my library files. An overview of this is the following is a technique that may be used for an ILS, GLS approach, or with an EN approach, but not recommended for VNAV, for obvious reasons that you will see after we set up the procedure. Normally, a profile is intercepted, that is, a glide slope is intercepted from below. And in this case, at Muscat, you would want to be at an altitude of 2,200 feet when established on the localizer before intercepting the glide slope. In some cases, this is impossible due to traffic and whatever, and ATC were forced to actually put you in a position where you were too close and or too high to capture the glide path. So there should be an attempt made, if possible, and at the same time, fly a safe, stable approach. Using the nav display will be a great advantage, especially in VS, to observe the arc with the vertical speed selected and at what position you will attain the altitude set in the MCP. That's what is meant by this paragraph. Use the autopilot. Before intercepting the glide slope, one prerequisite is that you be established on the localizer. So for this demonstration today, I'll make sure that we have established ourselves on the localizer before we can actually complete the maneuver you're going to see. In some instances, intercepting from well above the glide slope can cause problems with rapid pitch up and airspeed decreasing suddenly. So you want to make sure that you can use this procedure, and if not, go around. Let's have a look at the technique. Straight from Boeing's FCTM. Select approach on the MCP and verify that the glide slope is armed. So the first thing, localizer captured, but glide slope armed. Make sure you're configured in the landing configuration early. When we go back to the simulator, you'll see that I've done it downwind because we're anticipating this. So we want the slowest ground speed in order to effect the 1,000 to 1,500 feet per minute vertical speed recommended in a certain distance. So the slower the speed, the more effective the rate of descent is in getting us down to a position where we can intercept the glide path prior to the final approach fix. Using the nav display is a great tool, especially the vertical speed arc. You'll know where you're going to intercept by looking at the arc, and we'll talk about that in the demonstration. Select a vertical speed mode and set minus 1,000 to minus 1,500 feet per minute. That is 1,000 to 1,500 foot per minute descent rate. In order to capture the glide slope, prior to 1,000 feet above field elevation. Muscat is 15 feet above field elevation, or close to that, 15 or 25. In any case, we'll round it up to 100 and then add 1,000. So we will use 1,100 in the altitude window on the MCP once we get ready for this procedure. Remember the prerequisites. We have to have intercepted the localizer, and we have to be in a position where glide slope is armed, and we do that by selecting approach. All right, so let's go into the airplane and the simulator, and let's have a look at it. All right, we'll unfreeze the simulator, and if you noticed, we are configured in the landing configuration for flaps 30, and that we discussed in our briefing. The active waypoint is ITLAC, and we'll turn outside of ITLAC and give ourselves plenty of time for all of this. Now, in actual fact, let's make the final approach fix the active waypoint for an intersect 2. Unfortunately, we have a little simulator glitch where I can't extend the final fix. So we'll just carry on vectors and put ourselves in a position that we will not arm the approach until we are close enough so that we can actually make this demonstration. So in order to do that, I'm just going to go to Vorlock and intercept the localizer only until we actually are well above the glide slope. Then I'll arm approach, only because I am unable to do it with this little glitch we have in the simulator. It's all the same thing. It's all the same thinking. The whole idea here is be configured early so that you can have a minimum ground speed for this maneuver. So normally you would use, if you're going to extend the center line from the final fix, because in this particular maneuver, we want the final fix as the reference. But we'll trick the system here and just go to Vorlock to get the first requirement that is established on the localizer. And when we're well above the glide slope, then I'll arm approach. And then we can do the procedure to demonstrate it. I found many times in my flying career, we ended up high and had to do this particular procedure, which is in the FCTM, in order to salvage the approach and still remain safe and stable. These are the requisites of this approach. I'll return to the recording when we're a bit closer. So here we are in the position I mentioned. We had to trick the system so we could demonstrate it. We are on the localizer. As you can see, we're Vorlock. We have selected approach, and glide slope is armed. That's the second requisite. So we've completed that. So now, as you can see, the glide slope is way below us. So what we're going to do is select a lower altitude, and we said 1,100, and we'll do that. And then select vertical speed down of 1,000 to 1,500 feet. Let's go to 1,500 feet to start with and see where the arc, vertical speed arc, is on the nav display as we start down. So we are configured. There is a glide path. It's well below us, and we want to see where we're going to be. So let's continue that vertical speed so we can see where it is on the nav display. There it is on the nav display now, and we've got to have it so that we are in a position that at a slow, our current speed, that we can intercept the glide slope from above. So I'm having to cheat a little bit here just to do that. We're stable, we're looking good. So we've increased it, radio altimeter alive, we've got that, and landing check to go yet. So we're on the glide slope. We've captured the glide slope. So now we can set the missed approach altitude and go ahead and complete the landing checklist. So as you can see, it worked very effectively. And we briefed, we talked about it, and now we can do the landing check. And we'll say landing check complete. Missed approach altitude 6,000 feet set. I hope you enjoyed this video, one of many hundreds now in my library that you can actually purchase to view. Thanks for watching.